Good evening, ladies and gentlemen, and welcome to Circus of the Mind. Tonight, I'm going to be showing you our one and only amazing mathematical trick. And it all starts with 3 doors. Now, of course, you have to have some incentive to pick a door, don't you? I'm going to tell you that behind either A, B, or C, there is a car you could win. How phenomenal is that, ladies and gentlemen? So I'd like to ask any of the audience members right now in their head to pick a door. And I'm going to ask my stagehand here to pick one for me.
B.
Thank you. So he's chosen B, right here in the middle. So now I'm going to tell you, to, liven the odds up for you a little bit, that behind door C is a goat. Do you choose now to stick with B and hope that the car is behind B and that your initial idea and thought was right? Or do you choose to change what you previously thought and go with A? That is the question I'd like to pose to you, ladies and gentlemen. Do you change or do you stay? And I'm going to show you how, in a mathematical sense, whether you change or whether you stay the same, your odds of actually winning the car will change dramatically.
Okay, solution to the Monty Hall problem. It's quite simple, really. Now, if you're like me and didn't understand this at first, well, don't worry, because here is a much simpler way of understanding the Monty Hall problem. Now, you have 3 doors, and I have colored the door with the car as red, door that we have chosen in green, and the door definitely with the goat in blue. Now, these are all the scenarios that can happen. So, if the goat was in A and you choose A, then if you don't swap, you will win because you have chosen the one. But if you swap, you will go to either B or C, depending on what door the host shows you. So A, B, or C, you will win if you do not swap, but if you do swap, you won't win. Now, in the other circumstance, the car is at A, but you pick the door B. Now, in this case, you will win if you swap, because the host will have to show you C, and you will swap to go to A. But if you don't swap and you stay in B, you will not win. Similarly, in this circumstance, the same thing will happen. And so, in 6 out of the 9 overall probabilities, 6 out of 9 times, if you swap, you will win the car. But if you don't swap, 1 out of 3 times, you will win the car. So the percentage of winning the car has doubled when you do swap.